My name is Keshwani. It's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, the GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we're about to solve are the ones that you will find on page number 154. Please turn to it. Page number 154, and today is our lesson number 259. The very first problem that you see there, problem number 13 on the page, tells us that we are dealing with a rectangular garden. Number 13, we have a rectangular garden. They further tell us that this garden happens to be such that it is twice as long as it is wide. It is twice as long as it is wide. Another way of saying the same thing is that the length happens to be 2 times the width. They further tell us that the perimeter of this rectangle happens to be 360 yards. We are putting a fence around this piece of land, and we are told that the total fence that we will have is 360 yards, including the gate, which is another way of saying that the perimeter is 360. The question simply is, how much is the length? Let's find out, shall we? Since it is the length that we are interested in solving, here is our length, which is 2 times the width, and here is our perimeter, which is 360. Perimeter is equal to 360, which is equal to 2 times the length plus 2 times the width. Plus, we have to get rid of this w here because we are not interested in solving for the width, we are interested in solving for length. Let's express this w in terms of width using this equation here. This equation tells us that this implies that width must be half of the length. Width must be half of the length, which makes perfect sense because if length happens to be twice the width, then width would have to be half the length. Let's put it in here. 2 times L plus 2 times width, which we know is half the length. And the 2's drop out. We end up with 2L plus L, which is 3L. 3L equals 360. Divide both sides by 3, and we find that L equals 120. Nothing to it. Very simple, very straightforward. What the interesting part here is what we are about to do next, which is question number 14, which deals with the absolute value. Let's do that. Let's do the next one. Number 14, dealing with absolute value. Here's what we are told. Absolute value of y minus a half, we are told is less than 11 over 2. And the question is, which could be the value of y? Which could be the value of y? The answer choices that are given here is negative 11, negative 11 over 2, 11 over 2, 11, and 22. A, B, C, D, and E. There are 5 answer choices that are given to us. Obviously, what they are trying to tell us is that out of those 5, 4 of those are not possible. 4 of those are going to lie outside the area that we are interested in. Question is, which one of these 5 value actually lies within the interval that we are interested in? Let's find out, shall we? Now listen, before we actually start out with something as complicated as that, if it helps you, if it makes it easier for you to understand the concept, let's look at something simple. What exactly does it mean if someone tells us that the absolute value is less than 5? Absolute value of x is less than 5. Where does it fall? Where does it fall? Well, here's our number line. Here is 0, here is positive 5, and here is negative 5. Where is the absolute value of x going to be less than 5? Well, absolute value of x is going to be less than 5. If x happens to be between 0 and 5, let's say 4, x cannot be 6. If x were 6, the absolute value of 6 would be 6, and 6 is absolute value. X cannot be 7. Absolute value of positive 7, of course, is 7, which is not less than 5. X also cannot be negative 8. X also cannot be negative 8 because absolute value of negative 8 it's going to be positive 8, and positive 8 is not less than 5. We are told that the absolute value of the x is less than 5, which tells us that we are interested in this region. The x has to lie in this region, between here and here, between negative 5 and a positive 5. What this tells us is that we are looking at a scenario where either x is greater than negative 5 or x is less than positive 5. Those are the two scenarios we're looking at. Either x is greater than negative 5, either x is greater than negative 5 or less than positive 5. Let's put them together in one inequality. This is how it's going to look like. If we put them together, it has to be less than positive 5 or greater than negative 5. Voila. This is what we're looking at. Now, what we're going to do at this point is that we're just going to simply replace x with y minus 1/2. Pretend that our x equals y minus 1/2. So that's all it is. Pretend that our x equals y minus 1/2. So this here x equals y minus 1/2. And here instead of 11/2, we can't put it here. I just realized that I put down 5, not 11/2. But the idea does not change. So here, in this case, y minus 1/2 has to lie between positive 11/2 and negative 11/2. In other words, if we change this to 11/2, then this would have been negative 11/2. This would have been positive 11/2. And here, x equals y minus 1/2. So as x equals y minus 1/2, we just substituted. We replace x with y minus 1/2, and now we just have to solve for y. We see negative half here. We have to get rid of this negative half because we are interested in y. Let's add half. To all sides of the inequality. Notice how we speak when we're dealing with an equation. If we have an equation here, x plus 3 equals 4, and if you want the x by itself, what do we say? We say, let's subtract 3 from, here we would say, let's subtract 3 from both sides of the equation. We're not dealing with an equation, we're dealing with inequality, which happens to have three different segments. So here we have to say, let's add half to all sides of the inequality. We can't say both sides, there are three of them. Let's add half to all sides of the inequality, so that we can get rid of this negative half and a positive half will cancel each other out, and we're left with y. Y lies between this range here. 11/2 and half is just going to be 12/2. This is just 12/2. Which of course is 6. And here we will have negative 11 and a positive 1. A negative 11 and a positive 1/2 is just negative 10. Negative 11 plus 1 is negative 10. Negative 10/2. Negative 10/2, which is just negative 5. So it turns out that our y falls between negative 5 and a positive 6. Our y falls between a negative 5 and a positive 6. Let's make a note someplace. Or can we put it here? I need the room. Let's put it right here. Y falls between negative 5 and a positive 6. Now all we have to do at this point, all we need to do here is to go to our answer choices and see which one. It says which of the following could be. There is only one value here out of the 5 that falls in this range. Well, 22 is outside 6. The highest the y can be is, the highest value that y can assume is 5.999999 forever, but it can never be even 6. 22 is out of our range. 11 is out of our range. How about negative 11? Negative 11 is outside the range. We can only go up to negative 5. And negative 11/12 is negative 5.5. If this one is negative 5.5, this is also out of our range. Negative 5 is the farthest we can go there. The answer is C. The answer is C because 11/2 is 5.5 And since we are allowed to go all the way up to 5.999999, 5.5 lies in this range. Do you understand? That's all. The answer is that. What I want you to do at this point, listen very carefully please. If you are interested in getting some more practice on the absolute value problem, I have found out through experience, and I've been at it for some time here. Since 1989, I've been in this line of work where I've been tutoring for GRE, GMAT, SAT, all of these things that you see there. And I have found through experience that a lot of the times people stumble when they come across an absolute value problem, only because it's not something we deal with our daily lives. If you happen to be one of those people where you sort of somehow hesitate, and if you're not quite 100% sure of what you're doing there, and if you need extra practice, here are 3 videos here. You don't have to watch all 3 of them. Just type in this tag. Just put in TEAS, TEAS as in plural of T, TEAS Math Day 60. If you don't want to spend the time watching all of these 3 videos, at least watch Day 60. You'll get something out of it. You'll get more practice. You'll get an additional problem that you can practice on to better acquaint yourself with this kind of problem. They appear on the exam all the time. As a matter of fact, the very first data sufficiency problem, in the book, in this book, happens to be the one dealing with absolute value. Let's see if I'm actually correct. I'm going by my memory. Yes, it is. On page number 275 are the data sufficiency questions, and the very first one deals with the absolute value. And I have found that people sometimes get confused. If you happen to be one of those people, watch this video, Day 60. Just type in TEAS Math Day 60, and you will watch that video. In addition to that, we're going to do one more practice problem right now. A bonus problem, a problem that is not in the book actually. Let's do it together. Okay. I need a break, so I'm going to get out of your way so I can have my break. Okay, here we go. And this time around, the question is this. The question is, which of the following could not be the value of x? So here, we're dealing with the opposite, flip side of the coin. We'll be given with 5 answer choices. 4 of those 5 answer choices will be legitimate values of x, will fall within the range that we're interested in. Our job now is to locate the one that does not lie within the range. Just the opposite of what we just finished doing. And here are the answer choices. A, B, C, D, and E. Negative 16 over 5. Negative 3. Positive 3. Positive 5. And positive 13. And here's the question. Which of the following could not be the value of this thing? And here's the problem. And it should say x now, because in this problem I switched the variable to x. 5x minus 3 plus 7 is greater than 20. What I want you to do at this point is to pause the video. I want you to pause the video. I'll give you 5 seconds to do just that, to pause and unpause the video. I want you to solve this problem yourself. Once you've solved it yourself, then I want you to resume the video and then compare the work that you did yourself with the work that you and I will embark upon in a few seconds together. You understand? So here, I'll give you 5 seconds. Okay, here we go. The very first thing we have to do is, we are interested in this quantity, 5x minus 3, what appears in the absolute sign. We have to get rid of this 7. So let's do that. Let's subtract 7 from both sides. 7 drops out, and we find that the absolute value of 5x minus 3 is greater than 13. Now, if you don't want to deal with 5x minus 3, let's give it a new name. Let's call it a. Absolute value of a is greater than 13. And ask yourself, why would that happen? Why would the absolute value of a be more than 13? Ask yourself and draw a number line if it helps. If it helps, if you cannot picture it in your mind, draw a number line and ask yourself, why would that happen? Here's your 0, here's our positive 13, and here's our negative 13. Well, if x happens to be when I say x, I meant a. If a happens to be, now notice we're not talking about 5x minus, we're not talking about x, we're not talking about the values of x. These demarcations here, these demarcation of positive 13 and negative 13s pertain to a, not 5x minus, not x. Here we're talking about the allowable values for the quantity of 5x minus 3, not x, which is what we're replacing with a. A represents 5x minus 3. If a happens to be, say, positive 10, if a happens to be positive 10, well, the absolute value of positive 10 is not more than 13. It cannot fall in here. Can a be positive 15? The answer is yes. Absolute value of positive 15 is greater than 13. Of course, it needs to be greater than the absolute value of this quantity has to be more than 13. It can be here. This tells us that we are in this range right here. And we start from, and it's going to go on like this, starting from here, from this open circle. Let's cross out this 10. Let's erase this 10 so we don't get confused. And similarly, can x be negative 5? Again, I said x, I meant a. Can a be negative 5? Absolute value of negative 5 is positive 5, and positive 5 is not greater than 13. It has to be more than 13. Can a be negative 20? Can a be negative 20? The answer is yes, because absolute value of negative 20 is positive 20, which is more than 13. Again, we are in this range here. Starting from here, we're going this way. In other words, what we found just now, what we just found here is that either a has to be less than negative 13 or a has to be more than positive 13. That's it. These are open circles here. These are open circles because we do not have an equal sign. If we had an equal sign, then we would have closed this circle. This circle would have been closed. Because we do not have the equal sign here, this circle has to remain open. 13, and we just leave an open circle. This dot is nothing. That's it, we're done. Let's just replace the value of a. A, remember, was 5x minus 3. So 5x minus 3 is less than negative 13, and here 5x minus 3 is more than positive 13. And now we are ready to solve for x. We're going to pick up our story from here on the top. So here we have 5x minus 13 is less than negative 13. Something has gone wrong. We cannot have 13 both places. This is a 3, not a 13. Did I make a mistake? Yes, it's a 3. This is a 3, not a 13. Let's add 3 to both sides. 3 drops out and 5x is less than negative 10. Let's divide both sides by 5, and x is less than negative 2. X is less than negative 2. In other words, x has to be. So I'm going to erase this part because we no longer need it here. Where can I put it actually? I shouldn't have taken up this much room here. Should not have taken up this much room. 5x minus 3 is less than negative 13. Add 3 to both sides. 3 cancels out and 5x is less than negative 10. Divide both sides by 5 and x is less than negative 2. So that's one part of the story. Now let's do this part. 5x minus 3 is greater than 13. Let's add 3 to both sides. And 5x is greater than 16. 13 plus 3 is 16. That tells us that x is more than 16 over 5. X has to be more than 16 over 5, which is same as x saying that x is more than 3 1/5. X has to be more than 3 1/5. Now notice what happens. Now we're going to draw these again on the number line, and this time what we will be showing are the allowable values of x on the number line. This thing shows the allowable values of a, or allowable values of 5x minus 3. This shows allowable values of 5x minus 3. Now we're going to show right here the allowable values of x. So negative 2, there is 0, there is negative 2, and there is 1, 2, 3. This is positive 3, and this is going to be positive 3 and 1/5. It has to be more than that, or it has to be less than this, negative 2. And these are allowable values of x, which is what we're interested in. We're trying to figure out what values of x are allowed and in what range, and there are two parts to it. X has to be either less than negative 2 or x has to be more than 3 and 1/5. Anything that violates it here, it would not work. So let's first take a look at it. Negative 16 over 5. Negative 16 over 5. Well, negative 16 over 5 is going to fall here. It's going to be, this is your negative 3, and this is somewhere here. It's going to be negative 3 and 1/5. Negative 3 and 1/5 is same as negative 16 over 5. That one is fine. It has to be below negative 2 or above positive 3 and 1/5. Negative 3. Negative 3 is also fine. Negative 3 is to the left of negative 2. That is also fine. Positive 3. No. Positive 3 will not work. Positive 3 does not lie in the allowable range. It has to be more than positive 1/5. There you go. There's your culprit. How about positive 5? Positive 5 is fine. Positive 5 is going to be more than 3 and 1/5. And positive 13 is fine. Positive 13 is going to be more than 3 and 1/5. The answer is C. The answer is C. That was it. Make sure you watch the other videos I told you. Day number 60, and if you have the time, perhaps even day 58 and 59. And any time that you're interested in learning any particular math concept, the thing to do is just to type in the name of the concept. For example, you can just type, you can use this tag, just put in absolute value, and then my name, Keshwani, absolute value and Keshwani, and then search for look for this search term, and something will pop up. Something will pop up because I have close to 2,000 videos on my channel, and there are videos on just about any topic that you can find. Do you understand? I'll see you tomorrow, okay? Bye now.